Hello and good day. In Algebra, we are starting Unit 3, which is going to be all about graphing. And we're going to start with potentially learning just some new terms relating to characteristics of things that you'll see in graphs. Okay, and we're going to start with the term relation. The objective, CO18, is I can use relations to find the domain and the range. A relation is essentially a collection of ordered pairs. Okay, a collection of ordered pairs. And ordered pairs, as we know, are used to plot points on the coordinate plane. Ordered pairs are written in XY form, right? The X value always comes first, the horizontal axis, followed by the Y value, the vertical axis. But there are a couple different ways that we can represent ordered pairs, right? We can use an XY table, okay? Also called a function table. Have you heard it called that before? Function table, or an XY table, basically listing the X and the Y values of that relation. Or we can represent a relation on the coordinate plane, right? We can actually graph those ordered pairs to see what they look like once they're on the coordinate plane. And without going too far ahead here, I've got two of them here because there's something different about them. One is a line and one is a segment. What's the difference between a line and a segment? Kind of touching geometry a little bit here. Violet? Right, a line goes on forever and a segment stops. I think I've told you before that if you want to be kind of that smart aleck kid for your teacher, when he or she says, line up to go to lunch, say, actually, it's a segment. Okay, segment up would be the appropriate way to say it, right? The segment has a beginning and it has an end, right? Whereas a line goes on forever. And you can tell the difference because that line has the arrows on it, right? That's why it's called a number line, right? Because it goes on forever, whereas a segment has those endpoints with dots. But we'll get back to that in just a little bit. The domain of a relation, is that a word you've heard before? Domain of a relation. So we're going to learn something new today. Fantastic. The domain refers to the X values of a relation. Okay? The X values of a relation. What's another word that we can use for X values when we're talking about graphs? Kind of a vague question, but have you heard of, Drew? Horizontal, it's the horizontal axis. Have you heard of inputs and outputs? Yeah. Okay. Which one of those are the X variables, the inputs or the outputs? They are the inputs. You don't really need to know that for CO18, but we are going to talk about it in CO19, so a little bit of foreshadowing here. And then the range would be the Y values of a relation, also called the outputs. Okay. And so our objective today is looking at either an XY table or the graph of a line or the graph of a segment, be able to identify what are the inputs, what are those X values, the domain that's represented, and what are the outputs, the range, the Y values that are represented. Okay, you up for it? You don't have a choice, so I guess we just go on. Okay, all right. So in an XY table, the domain and range, and the XY table is probably the easiest one, because if I ask you what are the X values represented in this table, well, you just look at it, right? We would say the domain of this table, -10, -5, 2, 4, and 0. Right? They're just listed there. Okay? The inputs for this XY table are listed, and we would just write them down. Okay? The range would be -3, 0, 8, 2, and -1. What are the outputs? What are the Y values represented in this relation? An XY table is really good if you want to kind of like identify or work with specific ordered pairs of a relation. We're very specifically looking at the ordered pairs -10, -3, -5, 0, 2, 8, 4, 2, and 0, -1. Whereas the coordinate plane kind of gives you the whole picture, right? Going over to the line here, what x values are represented in the graph of a line? What x values are represented in the graph of a line? Do you know?
Is it 4 and -6?
4 and -6. So you're getting 4 and -6. I think it's actually three here. Because if you look at where this line's graphed, it kind of goes on the x-axis from about 3, right? And then it goes over to -6 on the x-axis there. But what did we say was true about a line? Why are those arrows important? Goes on forever. So even though the line, the actual drawing of it kind of stops here at +3, that arrow tells us it really goes on and on and on and on and on and on and on. And same thing down here, on and on and on and on and on. So if you think about it like that, is there really any x value that is not going to be represented here? I mean, 6, the x value 6 over here, that would be like up here, so it's not on the coordinate plane, but that's what those arrows mean. It does continue on forever. So are there any x values that are not going to be a part of that relation? No. Every x value is going to be part of the domain. And so what's that mathematical symbol that we use to show that every number is a part of it? All solutions, but in this case, in context, it means that every x number, there's an infinite number of x values that are part of this relation because that line goes on forever and ever. How about the range? The y values that are represented. I mean, on the graph, this line that's drawn here, kind of goes up to a y value of 7 and goes down to a y value of -6. But what do those arrows mean? Goes on forever. It's going to continue to climb up that y-axis, continue to go down that y-axis forever. So the range is also going to be that all reals symbol. Okay, Violet.
Whenever it's a line, is it always all solutions?
Yeah, isn't that nice? Yes. Whenever it's a line, it's going to be also, I should say, hold on, sorry. The exception to that is if it's a vertical or a horizontal line, because if it's a horizontal line, right, just coming down, say, like this. Sorry, if it's vertical, thank you. If it's a vertical line, just going up and down like that, the range is all reals, right? Because it's going to go down forever, the y-axis, and up forever on the y-axis. But the domain is only x equals 5, right? Because it's not going side to side at all. It's not covering any x values. 7 is never going to be a part of this relation because it's going vertical straight up and down, right? But as long as it's going diagonal, it will hit every x value and every y value at some point. Okay? Different from a segment, however, because a segment has endpoints. So kind of going back to Gino's thought from earlier, when we look at this domain, I keep putting the eraser in the wrong spot. We see that on the x-axis, it does only go from -1 to +5. It does not continue on forever. It stops there. It starts at an x of -1. It stops at an x of +5. So what's the domain? What are the x values represented here? I'll give you a hint. It's not -1, 0, 1, 2, 3, 4, and 5. Caleb?
Wouldn't you write it -1 equal to or greater than x?
So you're very, very close.
Oh, wait, no, I did it wrong. It's it'd be -1 is less than or equal to x. and 5 is greater than or equal to.
Right, or we could write that as an and statement, which says the same thing that you just said, but basically saying that x is between -1 and +5. Right, so in context, whenever ever going to use an and statement, well, when you're describing the fact that this segment covers every x value from -1 to +5, because we have to include things like fractions, mixed numbers, decimals, right? We can't just list -1, 0, 1, 2, 3, 4, and 5. This includes everything between there also. Okay, and that's the definition of this and statement here. X is between -1, +5. How about the range? I'll do this in another color so we can see. The segment goes from 7, that's its maximum y value point, and its minimum y value point is 1 there. Right? That's the section of the y-axis that it covers from 1 to 7. How do we write that? Again, using compound inequalities because we're super smart, because we just learned about those. James?
1 is less than or equal to x, and is less than to 7.
Good. Only thing I'm going to change about that is rather than x, it'll be y, because we're talking about the range. But yes, you got the main points there. 1 is less than or equal to y, which is less than or equal to 7, essentially saying that y is between 1 and 7. Okay, so domain, those x values that are being represented, the range, the y values that are being represented. So far, so good? Graphing fun? Yeah, okay. All right, so going on down the page a little bit here, we have, and then just remember the difference between a line and a segment. If it's got arrows on it, it will be those the all reals relationship. If it's a segment, it'll be a compound inequality. So it says make an XY table or a graph with a given domain and range. How can we tell if our representation will be an XY table or a graph? What about the way that this is being described to you here? Seba? Right. If the domain and range are simply listed for you, -4, -1, 6, 0, 2, that's an XY table. If it's a compound inequality saying that x is anything between -3 and 5, we can't make an XY table for that. We can't write out all those decimals and fractions and everything. That would take literally forever. Okay, so you can tell the difference by how it's presented. If it is listed out -4, -1, 6, 0, 2, 3, -4, 6, 10, -1, that's an XY table. Okay? If it's presented as a compound inequality, it's going to be a graph. So we're going to make a little makeshift coordinate plane here. That's fun. Okay? How are we going to graph a segment here that goes from -3 to +5 on x and +2 to +4 on y? Any thoughts? Yeah?
You first have to start by putting the numbers in up to 5, and then it would go over to it'd go up to 4 and over by 3. So it'd go 6 across up 2.
Are you fine when you say 6 across? Is that the difference between -3 and 5?
Yeah.
That actually be 8. Okay, but yeah, you're on kind of the right idea here. What Caleb was saying is that you have to look at the values that are provided, and those are kind of your important values on this coordinate plane. You can actually kind of math hack this and take the low end of both the domain and range and mark that as an ordered pair. If we take the low end of each of them, -3, 2, and plot that, and I'm just going to put just those numbers on here, just kind of keep it a little bit simpler. -3, 2, and then go to the high end of each of them. the maximum x value of 5, the maximum y value of 4, and take that as an ordered pair and plot it. So 5 is going to be somewhere over here. 4 is going to be up here a little bit. There's our segment, right? This segment has a domain. Those x values are from -3 to +5. And it has a range, the y values of +2 to +4. And you can get that pretty easily just by taking the low end of each of them and the high end of each of them and plotting those points. Okay? So to answer this question down here, how do you know if the relation is best represented as a table or a graph? Well, it depends on if it's listed, like it was here, or if it's given to you as a compound inequality, showing that everything between those two endpoints needs to be included, okay? And the endpoints are given to you hidden as ordered pairs there. Questions on any of this so far? So good. Okay. The second page. You get to practice a little bit. Let's just kind of briefly go over a couple of these. This first one here, table or graph? Table, it's listed. Second one, table or graph? Graph. What are the endpoints of my segment going to be? James?
2, 1.
2, 1, the low end of each of them, and 4, 5, the high end of each of them. Plot those points, connect them, and you've got your segment. Okay. Third one, table or graph? Graph. You can get the endpoints from the inequalities. Fourth one, table or graph? Table. And how much more we got to go? I think there's just two more in there. This one, table or graph? Graph. Last one, table or graph? Table. Okay? So the tricky part here, quote unquote, is getting those endpoints of that segment. If you know where to look, okay, they're given to you. All right. Anything else on CO18? Just kind of a brief intro to some terminology, domain and range, x values, y values that a relation represents. Nope. Yes. Yes, you may. So your homework for CO18 is to finish the second page, 6 of them to do, and we will stop this video, go on to the next, which will be CO19. So for now, that is how you math.